In this video, we're going to introduce the periodic table of the elements. This is one of the most important things that we've come up with as humans, as chemists, as scientists in general, to organize what we know about the elements that we have discovered in our universe. And so the periodic table of the elements is organized in such a way, this is the periodic table of elements. This is from a website I particularly like called ptable.com. It's my go-to periodic table if I'm using one on the internet. And this is a PDF version of this that you can download. It's available on the Moodle site. Anyway, this is our way of organizing a lot of information into one sheet of paper. So there's a lot to unpack here. So first of all, I'll use blue here. The thing to notice is that we have a bunch of squares, right? So we'll highlight hydrogen here. Each of these squares represents an element, and there's a bit of information in each of these squares. Number one, I switch to red here. We have this number here, which is for hydrogen 1, and this is the atomic number. And this is equal to the number of protons in that element. And one thing you'll see is that as you go from left to right across the periodic table, with hydrogen we start at 1, helium is 2, lithium is 3, beryllium is 4, and you can pretty quickly see that this is just listed in increasing number of protons for the different elements that we have. So we start at 1 and go up to 4. Now the big question may be, why are we skipping so much space, right? Why are we going from hydrogen in 1 on the left hand side of the table? Why is helium not just right next to it? And we will get into that later in the class. Actually, we'll get into a little bit right now, but more as to the reasons why and why it's certain numbers of things that we skip and things like that. It has to do with the number of electrons and how this works out. Okay, so we have the atomic number. And then beneath that, let's erase a little bit here. So you can, whoops. Erase the wrong thing. All right, we won't try to erase it. Beneath that we have the symbol. So right here we have, for hydrogen, that's H. That's not very easy to see. So we have H. This is what we call the element symbol. And this is generally how we will represent the different elements. And then beneath that, you can see you have the actual name written out. So hydrogen is H, and the full name is hydrogen. If we go over to helium over here, helium is HE, uppercase H, lowercase e, helium with the name underneath it. And then the last thing we have at the bottom of each square is, in hydrogen we have 1.008, helium we have 4.0026. This is the average atomic mass, which is what we discussed in the previous video. So this includes all of the different isotopes and everything like that. That's all averaged out based on their natural abundances. Okay, and so we have that repeated for every single element that we've discovered, and we've discovered up to 118. Now, many of those at the very bottom of the periodic table, like tennessine down here, they don't last very long. We won't see those very much. But the elements we'll see a lot of are the ones over here, along with many of these over here in the middle, transition metals. I don't know, depending what we're looking at, depending what you're working on. But we'll see a lot of these carbon, nitrogen, oxygen, fluorine. Those show up a lot in chemistry because they're really important to life. Other ways that the periodic table is organized is we have these rows. We call them periods. All right, let me just make some space over here and not delete the whole periodic table like I did earlier. But we have some space over here. So each row is called a period. So periods go that way. And each column is called a group. And we can see they're numbered here. So period 1 just has hydrogen and helium. Period 2 has lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And period 3, etc. We can see these. And then the different groups as we go down are the columns. Now, why do we organize it this way? Well, the groups tend to have similar chemical and physical properties. For example, with the exception of hydrogen, the first column, the first group, is known as the alkali metals, and these all are very reactive with water. They are all quite light metals, and they have very similar chemical properties in the sense that they react in very similar ways. Now, in some ways they change. As you go down the group, they become more reactive with water. Lithium reacts pretty vigorously with water, but it's not too bad. But when you get down to cesium, it's an explosive reaction with water. So it has similar properties, but not exactly the same as you go down a group. And as we go through the class, we will start to learn about trends in the periodic table as you go down groups and as you go across periods. There are different trends that we know, and we can interpret once we know more about electrons and protons and how they are, and neutrons and how they're organized in atoms. We'll understand why there are, number one, these gaps, and why we get certain trends and different properties. But for now, we'll have in the next video a little bit more about different areas of the periodic table and how it's organized.